Okay, I'm going to talk about finding the distance from a point. In this case, I'm calling this point Q to a plane. So if you make a little right angle here, go straight up to the point, I want to find out what this distance right here is, the distance from the point to the plane. Now here's the way we proceed. We just choose another point on this plane. I'll call this point P. And what I want to do is I want to make a vector with the initial point P and the terminal point Q, and of course I'll just call that vector PQ. Now what we've done is we'll look upon this as that vector. Okay. Now what I'm going to do is I'm going to take this vector and project it over onto the normal vector. Now remember, the normal vector here makes a right angle with the plane. So what's going to happen is I'm going to project this vector over to the normal vector, as you see here, where this is the projection right here. This distance here is the projection. And then I'm going to get the magnitude of that vector, and that will be the distance that we seek, because that is the same distance as this. Now remember that the formula for projection, so if I want to project this vector PQ onto the normal vector, it's going to be PQ dot the normal vector over the magnitude of the normal vector squared dot the normal vector, or times the normal vector, I should say, because this right here is going to be a scalar. So what we need to do, since that's the process, what we need to do to get our formula is just simply determine, well, what is the magnitude of this vector? Well, the magnitude of this projection would be this, wouldn't it? It would just be the square root of PQ dot N over the magnitude squared times N1 squared plus N2 squared plus N3 squared. In other words, the components of the normal vector. Now, and of course this part right here would be squared. Now if I take the square root of this thing that's squared here, what's going to happen is on the outside you're just going to get this. You're going to get the absolute value of PQ dot N, and down in the bottom I'm just going to get the magnitude of N squared, and then I have this left. I have N1 squared plus N2 squared plus N3 squared, which this is the magnitude of N. So now here's what I have. I have the absolute value of PQ dot N. Now it's absolute value and not magnitude, because this dot product, remember, is a scalar. And down here we have the magnitude of N squared, and this right here is of course the magnitude of N. This will get rid of one of those, and here's what we have for the formula of the distance between Q and the plane. And that's our formula right there. Now let's see how this is going to work then. Let's suppose I want the distance between this point, 1, 5, negative 4, and this plane. Well, here's what I can do. I can say, well, I'm going to need a point P first of all. I've got this point Q. I'm going to need a point P. Just any point on this plane will do. Well, an easy one to get would just be if I let x equals 0, y equals 0, and then find out what z is. Well, if x and y are 0, then I have 2z equals 6, and that means that z equals 3. So I have this point P, which is 0, 0, 3. Now I can find PQ. PQ is going to be 1, 5, negative 7. Now remember, we can read what the normal vector is directly from the plane. It's 3, negative 1, 2. It's these coefficients. So the normal vector is 3, negative 1, 2. Now we use our formula. We're going to take the absolute value of 1, 5, negative 7, dot that with 3, negative 1, 2, and divide it by the magnitude of n, because remember what we're doing is we're projecting PQ onto n. So we divide by the magnitude of n, which is 3 squared plus negative 1 squared plus 2 squared. And let's see what we have here. Now up top we have 3 minus 5 minus 14. And down on the bottom we have the square root of 9 plus 1 plus 4. And let's see what that gives us. This gives us negative 19. Well, it's 3 minus 19. And down here we have square root of 14. Okay, so 19 minus 3, that would give us negative 16. So here's what we've got. We've got 16 over the square root of 14. And that's how we find the distance from the point, this point, to this plane. Now, there is a shortcut that you will find, but this is the shortcut that is in your book is just a formula that you can use. You can look that up, and I'll talk about that next time we have class.